We thought we knew the story of the universe. Everything began 13.8 billion years ago from absolute nothingness, and we were the children of this singular cosmos. This was our unchanging truth. But we were dead wrong. Humanity turned its sharpest eye, James Webb, to that moment of beginning. But the telescope didn't find a beginning. It found an inheritance. It saw giant black holes billions of years old that shouldn't have been there when the universe was only 470 million years old. It detected galaxies that were chemically impossible dirty, meaning old. But the real shock wasn't the discoveries themselves. It was the one staggering truth they all pointed to: our universe is not alone. If you too want to see how what we thought was a beginning was actually a result, then subscribe to the channel. Because now you will see the concrete evidence Webb found. Evidence that suggests we are living inside another universe. We're starting. For years, we thought the story of the universe was clear. We believed everything started 13,800 million years ago, from a single point of infinite density. We thought that from the moment of that Big Bang, the universe was constantly expanding and cooling. But then humanity sent a giant eye into the ice-cold void of space, a full 1.5 million kilometers away from Earth, the James Webb Space Telescope. This telescope was built to capture that first faint light that glowed after the Big Bang. Yet, when the first images fell onto our screens, scientists did not see what they expected, because in those first pictures, there were no chaotic, newborn clouds of debris, and what they saw fundamentally shook everything we thought we knew. That is why our standard model of the beginning of the universe stands before a giant question mark. Because, according to this model, the universe should have formed slowly after the Big Bang, just like a tree slowly sprouting from a seed. The formation of the first stars and galaxies should have taken hundreds of millions of years, and these first structures were expected to be small, irregular, and primitive. But James Webb looked back in time, to just a few 100 million years after the Big Bang. Yet, there were no baby galaxies there. Instead, there were massive, perfectly formed, mature systems that looked as if they had gone through billions of years of evolution. This was like looking into a kindergarten and seeing bearded, wise philosophers. Some of these galaxies, long before the time needed for their formation, glowed with an unbelievable maturity. So how could this be possible? How could the universe create such wonderful complexity and order in such a short time? This impossibility brought a radical theory, once only whispered in the corridors of science, to the forefront. What if the Webb telescope did not photograph the absolute beginning of existence? What if this light, which gently fell on its detectors after a journey of billions of years, was showing us the signs of a much older lineage? It is at this point that an idea both radical and poetic is proposed. This idea says that our universe was born inside a giant black hole, within a much larger, much older parent universe. Imagine this for a moment: an infinite, massive parent universe, filled with galactic wonders we can't even dream of. In this ancient void, a star dozens of times more massive than the sun dies. It collapses under its own relentless gravity. Matter is compressed so densely that space itself bends, and time stops. A black hole is born. From the outside, this is an infinite sphere of darkness we call the event horizon, from which no light, no information can ever escape. But what happens inside? Albert Einstein's theory of general relativity opens the door to a fascinating possibility. Because when the matter at the core of a black hole is compressed to an extreme degree, instead of disappearing into an infinite singularity, an immense quantum pressure could trigger a bounce, a kind of reverse collapse, a brand new beginning, because, for an observer in that region, this bounce would look just like how we describe our own Big Bang: the sudden, mind-bogglingly rapid expansion of space, time, and energy from an infinitely dense point. Therefore, what we call the Big Bang might actually be the first deep breath of a new cosmos, in the belly of a collapsing star. This idea offers a way to explain the impossibly early and mature galaxies seen by Webb. Because, These galaxies might not have started from scratch. Perhaps they received an inheritance from the collapsing star, from the parent universe itself. Perhaps this maturity is not a paradox, but proof of a family tree. But it is not just philosophical beauty that supports this theory. It is here that scientists discovered a chilling mathematical symmetry. This discovery was so shocking that at first it was thought to be a coincidence. If you take the estimated total mass of our observable universe, that is, if you add up the hundreds of billions of stars in each of the hundreds of billions of galaxies, the endless clouds of dark matter, and that delicate mist of interstellar dust, and put it all together, you get a number that transcends our imagination. It is a colossal figure. Now, if you were to calculate how large a black hole would have to be to contain all this mass, the size of its event horizon would match exactly with the outer boundary of our observable universe, 1 to 1. Is this just a numerical coincidence, or is this the ultimate proof, written into the cosmos itself? Perhaps when we look to the edge of time and think we see infinity, we're actually looking at the inner surface of the shell we were born in. The knowledge of this possibility should not frighten us. On the contrary, it holds a deep, almost comforting peace. Because it means we're not drifting in an empty, cold void. We are safe. We're in a home. But how does this massive invisible structure work? How can the physics inside a black hole explain the expansion of our universe and the early galaxies Webb saw? To answer these questions, we must first understand the nature of these mysterious cosmic giants, because we need to understand that black holes are not just the destructive monsters we've been taught they are. In fact, in the infinite wisdom and symmetry of nature, rarely is anything just destructive. Because, in the universe, destruction and creation are often two sides of the same silently spinning coin, and on the other side of that coin may lie the secret of our existence. Because, when we look with high-precision telescopes like NASA's Chandra X-ray Observatory, or the incredible Event Horizon Telescope that gave us the first direct image of a supermassive black hole's shadow, we don't just see an empty darkness. Instead, we see glowing, swirling rings of matter caught in an ancient spiral dance. This matter is heated to millions of degrees by extreme friction and relentless gravity. Because of this, it shines brighter than an entire galaxy. Before it reaches that point we call the edge of eternity. But what exactly is this boundary, this event horizon? Because it's crucial to understand that what astronomers call an event horizon is not a physical wall. It's not a solid object you can crash into, not a barrier of stone or metal. Instead, it is an invisible, absolutely smooth threshold in the complex geometry of space-time, a pure mathematical line. When a star many times heavier than our own gentle, warming sun reaches the end of its life and consumes the nuclear fuel in its core, it can no longer support its own enormous weight outwards. Because of this, it collapses in a silent, dramatic implosion of matter. Gravity, that quiet shaper of the cosmos, compresses the matter so incredibly that even the most resilient atoms are simply crushed. Space itself is warped so powerfully by this immense density of mass that it forms an infinitely deep valley. And from this valley, nothing, absolutely nothing, can ever escape again, not even light, which travels through the void at about 300,000 kilometers per second. This is the classic, just familiar picture that physics has painted for decades. But now let's expand this picture with the boundless imagination of theoretical cosmology. Let's gently turn it like a leaf in the wind. What really happens to all this information? All this condensed energy and matter that crosses the event horizon and plunges into darkness? Does it really fall into an infinitesimally small, meaningless point? A singularity where all known laws of physics cease to exist? It is right here that quantum mechanics, which describes the world of the smallest particles, and Albert Einstein's general theory of relativity, which governs the large and heavy, seem to stand in a silent, unresolved conflict in the heart of darkness. Because some of the brightest and boldest minds of our time have suggested that the extreme gravity at the center of a black hole doesn't just destroy space, but rather inflates it, forces it to change. Instead of ending in a strange infinite singularity, the collapsing compressed matter bounces back under unimaginable quantum pressure. This bounce, this massive cosmic leap, interestingly, does not happen in the same space the matter originally came from. Space itself inflates inwards, forming a new bubble, creating a completely new, independent region of space-time. It creates a new universe, a pure, fresh baby universe. This universe is forever safe and hidden behind the impenetrable, protective curtain of its massive parent universe's event horizon. If we accept this breathtaking, almost poetic hypothesis as true even for a moment, the meaning and essence of our own cosmic origin changes radically. Because then the Big Bang, which we saw as the beginning of everything, was not a mystical explosion from absolute nothingness. It was the bright germination of this quantum mechanical bounce. It was precisely that moment when the energy from a collapsed star from a superior and unknown reality flowed into a new, pristine, and empty space and began to expand. And it is precisely on this elegant theoretical bridge that the surprising four fresh observations of the James Webb Space Telescope come together almost magically. Scientists from NASA and ESA looked into the incredible depths of the cosmic dawn with this telescope's sensitive infrared instruments, NIRCam and MIRI. They captured light from galaxies that had travelled for more than 13 billion years in the expanding universe, before finally hitting our mirrors. And what did they find? It stunned the astronomical community into a deep silence. Because these discoveries have caused us to question even our most fundamental assumptions about the origin of the universe, and have sent us on a new and exciting journey towards the deepest secrets of our own existence. These whispers and theories are exciting. But now comes the real shock, because beyond these theoretical whispers, there is concrete, staggering data reflected from Webb's golden mirrors. This data not only supports the theories, but also presents incredible discoveries that are forcing us to rewrite the books on cosmology. Here are those findings, and it was at that very moment they encountered JADES-GS-Z13-0. This galaxy should not have existed. But it was there. Its light had been reaching us for over 13 billion years. This meant we were seeing it as it was when the universe was only 300 to 400 million years old. On cosmological scales, this is a blink of an eye. According to standard models, a galaxy at this age should have been small, unstructured, and weak in star formation. But JADES-GS-Z13-0 was not like that. It was too bright, too mature. Its mass was estimated to be hundreds of millions of solar masses, and its ability to accumulate this mass in such a short time caused physicists to use the word impossible. Because, in such a young universe, there was no known mechanism that would allow matter to accumulate so quickly and form such a large structure. Because there shouldn't have been enough building material in that early period of the universe. Therefore, this discovery was initially considered a measurement error. But repeated analyses yielded the same result. The scientists were stunned. This meant the universe might have cheated somehow, used a secret starting advantage, but the shocks didn't end there. Because Webb looked even deeper, and there, at the dawn of the universe, a much larger monster was hiding. This galaxy, named UHZ1, was one of the most distant galaxies we have ever observed. Its light had set off when the universe was only 470 million years old. But the real shocker about this galaxy was what it concealed at its centre. Joint observations with the Chandra X-ray Observatory revealed a massive supermassive black hole there. The mass of this black hole was between 10 to 100 million times that of the Sun. This number alone was incredible. But the real impossibility was this. The mass of this black hole was almost equal to the total mass of the billions of stars in its own host galaxy. This was an unprecedented situation. Because, even in our own galaxy, the Milky Way, the supermassive black hole at the centre accounts for only 0.1% of our galaxy's total mass. And the Milky Way had more than 13 billion years to develop. How did the black hole in UHZ-1 reach such a colossal size in such a short time? This was a paradox known in science as the heavy seed problem. Black holes were supposed to start with the collapse of a single star and grow slowly over billions of years by swallowing gas and stars. This process takes time. But the black hole in UHZ-1 defied these rules. Its existence completely demolished the standard models of galaxy formation. And now comes the decisive blow. Webb didn't just find mature galaxies or massive black holes. The chemical composition of these early structures also held a great secret. Because these young galaxies were surprisingly dirty, they were full of heavy elements. Scientists call these heavy elements metals, everything other than hydrogen and helium. Yes, but these metals are not produced in the Big Bang. They are forged in the burning cores of stars. When a star completes its life and explodes as a supernova, it scatters these heavy elements into space. The next generation of stars and planets forms from this enriched material. This process needs to be repeated many times. It is a process of accumulation. Therefore, the first galaxies in the universe were expected to be composed almost entirely of pure hydrogen and helium. But galaxies like JADES-GS-Z13-0, found by Webb, carried traces of elements like carbon, oxygen, and nitrogen, and they did so in much higher quantities than expected. This meant that many more generations of stars must have lived and died in the first few 100 million years of the universe than we thought. Fitting so many star life cycles into such a short time frame was almost impossible with current theories. This showed that the universe's chemical evolution clock was running at a speed far beyond our predictions. These results pointed to the existence of a cosmic family tree. Perhaps these galaxies didn't start from scratch. Perhaps they inherited an enriched legacy from a previous universe. This was no longer a handful of anomalies. This was a systematic challenge to our understanding of the fundamental workings of the universe. How can we bring all these impossible findings together, these galaxies that shouldn't be there, these unexplained black holes, and this early chemical richness? What do these discoveries mean as a whole? They all seem to point to a common conclusion. The universe matured much faster than we thought. But what was the engine that provided this speed? These findings bring us back to that radical idea we mentioned earlier. If our universe was born inside a black hole, the seeds of these early structures may have come from a place that existed before our universe. This is no longer just philosophical speculation. This is a possibility that Webb's data is pushing us towards. But to support this theory with concrete evidence, it's not enough to just look at these early monsters. We also need to understand the larger structure of the universe, the invisible skeleton that holds everything together, and for this reason, scientists turned their telescopes to a massive structure at the dawn of the universe. Because Webb didn't just find isolated galaxies, it also saw the first threads of the cosmic web that connects these galaxies to each other. Because Webb didn't just find isolated galaxies, it also saw the first threads of the cosmic web that connects these galaxies to each other. This massive structure is the grandest architecture of the universe. Computer simulations have long predicted that the universe should resemble a giant web made of dark matter filaments billions of light years long. But to see the first seeds of this web was something else entirely. Webb discovered a massive, 3 million light-year long filament connecting more than 10 galaxies when the universe was only 830 million years old. At the center of this structure was a bright quasar, an actively accreting supermassive black hole. This discovery was the first direct evidence that galaxies are not randomly distributed, but rather flow along this invisible web like water in rivers. But again, there was the same problem. This structure was not expected to be so prominent and organized at such an early date. This showed that even the web itself was woven much faster than we had assumed. The fact that dark matter clumped so quickly and formed such clear filaments once again pushed the limits of standard cosmology models. Because these structures were supposed to emerge from the slow and patient work of gravity, it should have taken billions of years. But in this childhood phase of the universe, it was as if someone had set the cosmic loom to its highest speed. This was a strong hint that those heavy seeds, the pre-existing gravitational centers, might have shaped not only individual galaxies but also the larger structure of the universe. But the only anomaly Webb found did not come from the early times of the universe. The telescope revealed something closer to our own galactic neighbourhood, but still unexpected. Let's fast forward in time and look at a period when the universe was about 3 billion years old. Scientists were looking at an object they called Schrödinger's galaxy candidate. This name came from its strange, dual nature. Because, from a distance, it looked like the result of a collision between two different galaxies. But, when Webb's sharp eyes looked deeper, a completely different story emerged. It wasn't two separate galaxies, it was a single galaxy. But somehow, it seemed to be at two different distances at the same time. One image of it was much closer than the other. How could this be? The answer lay in Einstein being right once again. The effect of gravitational lensing. Between the candidate galaxy and us, a massive galaxy cluster in the foreground was bending space-time so strongly that it split the light coming from behind and directed it along different paths. One of these paths was longer than the other. Therefore, we were seeing two images of the same galaxy at two different times, simultaneously. One image was about 300 million years older than the other. This was living proof that the universe itself was acting like a time machine. This discovery alone did not refute any theories, but it showed how strange and deceptive the universe can be. It reminded us that not everything we see is as it seems, and most importantly, it was indirect support for the theory that the universe exists within a black hole. Because, according to this theory, the bending of space-time is not just a local effect. It is the fundamental architecture of the universe. We are living inside a massive gravitational well, and every ray of light in this well travels on a curved, distorted, and sometimes duplicated path. But perhaps the most philosophical and shocking of all these discoveries is the one concerning the nature of time. Because, if these early galaxies and black holes were formed from seeds from a parent universe, it means the Big Bang was not an absolute beginning. It shows that our arrow of time originates from an event that had a before. The theory of cosmological natural selection, proposed by physicist Lee Smolin, goes one step further. According to Smolin, universes reproduce through black holes. The more black holes are formed in a universe, the more baby universes it creates. And these baby universes inherit the fundamental physical constants of the parent universe with slight variations. This is very similar to biological evolution. Universes that are conducive to life, those that produce many black holes, have more offspring. And what does it take for a universe to produce many black holes? It needs plenty of massive stars. And for these stars to exist, the gravitational constant, nuclear forces, and other fundamental constants must be fine-tuned with incredible precision. If they were even slightly different, stars would either not form at all, or they would collapse immediately without forming black holes. According to this theory, it's no coincidence that our universe is so perfectly tuned for life. Because ours comes from a lineage of universes that has been the most successful at producing black holes over countless generations. We are a branch on a cosmic evolutionary tree where the fittest have survived. The impossible early structures found by Webb could be the first indirect evidence of this theory. Why? They could be cosmic fossils showing that our universe truly had a parent and inherited a head start from it. This early maturity is not a paradox. It is proof of a family tree. All these results come together to form a revolutionary picture. Mature galaxies, massive black holes, early chemical richness, and a pre-organized cosmic web. They all point in the same direction. Our standard model is incomplete. The beginning of the universe is much more complex and mysterious than we thought. But how does this new model, the universe inside a black hole, fit the pieces of this puzzle together? How exactly does this mechanism work? What is a quantum bounce? How does the physics inside an event horizon create the expansion and structure formation we observe? It's time to move from theories and shocking findings to the technical details of how this incredible cosmic engine works. Because the laws within this massive structure form the basis of our reality, and when we understand them, it will completely redefine our place in the universe. But how exactly does this incredible cosmic engine work? What physical laws allow one universe to be born inside another? It's time to move from the shocking discoveries to the depths of the elegant and powerful mechanisms that form the basis of this theory. Because when we understand these details, we will see why the impossibilities found by Webb were actually inevitable. Now let's shift down a gear and take a calm journey into the heart of this fascinating physics. Our first stop on this journey is the moment where it all began, the quantum bounce. To understand this concept, imagine a compressed spring. The more you compress the spring, the more potential energy it stores. And at some point, either your hand gets tired or the spring structure gives way, and it suddenly springs back, releasing all its energy. What happens at the center of a black hole is very similar to this. But what's being compressed here is not a spring, but space-time itself. According to general relativity, the matter of a collapsing star should fall into a singularity of infinite density, a point of zero volume. But this violates the rules of quantum mechanics. Because, in the quantum world, nothing can be confined to an absolute 0 point. The uncertainty principle states that you cannot know both the position and momentum of a particle with perfect accuracy at the same time. When you try to squeeze something into an infinitesimally small space, its momentum, its energy, rises to infinity. It is precisely at this point that the two great theories of the universe, general relativity and quantum mechanics, collide, and from this conflict, a new physics is born, which we call quantum gravity. According to this new physics, when matter reaches an incredible limit, the Planck density, gravity becomes a repulsive force. This corresponds to a density of about 5.1 times 10 to the power of 96 kilograms per cubic meter. This is completely contrary to the nature of gravity as we know it. But under these extreme conditions, the fabric of space-time begins to resist further compression. This immense quantum pressure stops the collapse and reverses it, just like the released compressed spring. This bounce triggers what we perceive as the Big Bang. But this is not an explosion from nothingness. This is the reorganization of matter and energy from a previous universe in a new space-time bubble. This mechanism elegantly solves the heavy seed problem found by Webb. Because the new universe doesn't start from scratch. It inherits the density fluctuations and fundamental properties of the collapsing star, the parent universe. This is just like a newborn baby carrying the genetic code of its parents. This cosmic DNA shapes the structure of the new universe from the very beginning. Therefore, the massive early galaxies and black holes seen by Webb are actually echoes of structures even older than our own universe. They are the fossils of the parent universe. But this mechanism not only explains early structures, it also sheds light on one of the most fundamental features of our universe, the cosmological redshift. This concept is the most basic evidence of the expansion of the universe. Just as the siren of an ambulance moving away from us sounds lower pitched, or lower frequency, the light from galaxies moving away from us also shifts towards the red end of the color spectrum. The reason for this is that the wavelength of light is stretched as the space between us expands. By measuring the redshift value, denoted by Z, astronomers can calculate how far away a galaxy is and how fast it is moving away. For example, one of the most distant galaxies found by Webb, GADES-GS-Z13-0, has a redshift of Z equals 13.2. And this means that the wavelength of light from that galaxy has been stretched more than 14 times its original length due to the expansion of the universe. In the standard model, this expansion is a result of the initial push of the Big Bang, but in the black hole universe model, there is a much more continuous and dynamic process behind this expansion. According to this model, the baby universe we live in is a black hole within a parent universe, and this black hole continues to swallow matter and energy from the parent universe. Just like a whirlpool pulls water into it, the more mass a black hole swallows, the larger its event horizon becomes. It is precisely this continuous growth of the event horizon that is perceived by us observers inside as the expansion of our universe. Therefore, the redshift is not just a faint echo of a past explosion, it is the living, instantaneous evidence of the ongoing flow of matter and energy from the parent universe into our own. This mechanism also sheds light on another observation that the standard model has difficulty explaining: the accelerating expansion. Observations have shown that the expansion of the universe is not slowing down, but is actually accelerating. This mysterious acceleration is called dark energy. In the black hole model, this acceleration can be explained by an increase in the feeding rate of our black hole from the parent universe. This brings us to another critical technical detail: the holographic principle. This principle is one of the most surprising and profound consequences of quantum gravity theory. Simply put, this principle states that all the information in a three-dimensional space can be encoded on a two-dimensional surface that encloses that space. Just like a hologram on a credit card carries the information of a three-dimensional image on a two-dimensional surface. This idea originally arose from attempts to solve the information paradox of black holes. When something falls into a black hole, is the information it carries, for example its mass, spin, composition, lost? Quantum mechanics says that information can never be destroyed. The holographic principle suggests that this information is not lost, but is instead stored on the event horizon of the black hole, on its two-dimensional surface. Now let's apply this principle to our own universe. If our universe is indeed inside a giant black hole, then our three-dimensional reality, height, width, depth, could be a hologram projected from the two-dimensional surface of the massive event horizon that surrounds our universe. We, stars, galaxies, planets, and even our thoughts could be three-dimensional projections of information encoded on that cosmic surface. This may sound like science fiction, but it is mathematically consistent. This mechanism explains some of the fundamental properties of our universe in surprising ways. For example, the total information content of the universe seems to be proportional to its surface area, not its volume. This is exactly what the holographic principle predicts. This model is also consistent with Webb's results. Because, if our 3D reality is projected from a 2D surface, then the flow of information on that surface directly affects the formation of structures in our universe. New matter and energy falling into our black hole from the parent universe adds new information to the holographic film on the event horizon. And this new information manifests in our universe as new structures, namely early galaxies and stars. This provides a physical mechanism for how heavy seeds emerge. They are clusters of information originating from the parent universe and holographically projected into our universe. This also explains why the universe appears so organized and web-connected. Because everything originates from a single fundamental information surface. But how does this holographic projection affect our perception of time and space? And most importantly, is there a counterpart to this theory in Einstein's equations of relativity? Because, to understand if this model really works, we need to delve even deeper into how time and space behave inside the event horizon. And for this reason, we must dive into one of the most confusing and fascinating consequences of Einstein's equations: the role switching of space and time. To understand this concept, let's think about our daily experiences. For us, space is an arena we can move in. We can move forward, backward, right, left, up, and down. Time, on the other hand, is a one-way, unstoppable river. It always flows from the past to the future. Because we cannot avoid going to tomorrow. But when you enter the event horizon of a black hole, these roles are surprisingly reversed. The mathematics of general relativity shows that inside the event horizon, one spatial direction, the direction towards the center, takes on a time-like character. What does this mean? It means that falling towards the center is no longer a movement in space. It becomes a movement in time. Just as tomorrow is an inevitable future for us, reaching the center is an inevitable future for an observer inside the event horizon. You cannot resist it. No thrust, no rocket can save you from this fate. Because this is no longer trying to go back in space, it is trying to go back in time. This mechanism can explain why our universe has a one-way flow of time and why it is expanding in all directions. If we are inside a black hole, the expansion of our universe in all directions is actually a reflection of that inevitable fall towards the center. For us, expansion is the relentless flow of matter and space towards the center of that collapsed star in the parent universe. This is the origin of what we call the arrow of time. The second law of thermodynamics states that entropy, shocks or disorder, tends to increase over time in a closed system. This law explains why time flows in one direction. But the most fundamental answer to the why question lies in the initial conditions of the universe. The black hole universe model provides this initial condition. Because this space-time roll, reversal inside a black hole, inherently creates an arrow of time. This is a fundamental geometric property that explains why our universe has a sense of a beginning and a future. But this geometric structure affects not only time, but also the distribution of matter in our universe. This brings us to the next important technical detail: initial fluctuations and structure formation. As we have seen, the universe is not perfectly smooth. Galaxies, stars, and planets are places where matter has clumped together. For these clumps to exist, very small density differences, or initial fluctuations, must have been present in the early universe. In the standard cosmology model, these fluctuations originate from quantum fluctuations during cosmic inflation, which is assumed to have occurred in less than a trillionth of a second after the Big Bang. These fluctuations would then have been frozen to macroscopic sizes by the enormous expansion of the universe at that time. This is a very successful theory. But the black hole universe model offers a more direct and less speculative origin for these fluctuations. In this model, the initial fluctuations are inherited from the collapsing star in the parent universe itself. Think of it this way: when a giant star collapses, this process is not perfectly symmetrical. Different layers of the star have different densities and temperatures. The star rotates, which creates complex eddies and fluctuations in its structure. When the star collapses below the event horizon, all these irregularities are not destroyed. When the quantum bounce occurs, these density fluctuations are imprinted on the fabric of the newborn universe. These are the initial fluctuations we observe. The beauty of this mechanism lies in its simplicity. It does not require an additional hypothetical period like inflation. It uses a process we observe directly, the death of a star, as the basis for the larger structure of the universe. These inherited fluctuations are precisely those heavy seeds that Webb found. They were gravitationally denser regions from the very first moments of the universe. Therefore, it was inevitable that normal matter would gather in these regions and form galaxies and black holes with surprising speed. In the standard model, gravity would have to slowly gather matter over billions of years to form these structures. But if the seeds are already there, the process proceeds much faster. This is like a seed planted in fertile soil. It grows much faster than a seed trying to survive in barren land. Therefore, the impossible early maturity seen by Webb is actually a natural consequence of these inherited initial conditions. And finally, this model explains one of its most elegant aspects: why the fundamental constants of our universe appear to be so perfectly fine-tuned for life. The mechanism of cosmological natural selection. As we mentioned earlier, physicists have long realized that if fundamental constants such as the gravitational constant, the mass of the electron, or the energy density of space were just a hair's breadth different, life as we know it could not exist. This fine-tuning problem is seen by some as evidence of divine intervention, while others consider it a lucky coincidence. But cosmological natural selection offers a third way. It is not a coincidence, it is an evolutionary result. Lee Smolin's theory assumes that universes reproduce through black holes. Each black hole is potentially the seed of a new universe, and each new universe inherits the physical constants of the parent universe with small vertical bar random variations. Now think of biological evolution. Organisms that are best adapted to their environment survive and produce more offspring. In Smolin's model, the fitness criterion is to produce the maximum possible number of black holes. Because the more black holes you produce, the more likely your lineage is to continue. And what does it take for a universe to produce many black holes? It needs to produce long-lived Kamnekyan, massive stars. And to produce such stars, the physical constants must be within an incredibly narrow range. For example, if the nuclear forces were slightly weaker, heavy elements like carbon and oxygen would not form in the cores of stars. This would mean there would be no raw materials for planets and life. If gravity were slightly stronger, stars would burn too quickly and could collapse before forming black holes. Therefore, the physical constants that maximize black hole production are also the constants that support the complex chemistry and long-lived stars necessary for the existence of life. Our universe seems so perfect for life because it is the product of a lineage that has been the most successful at reproduction over countless generations of universes. This offers a surprisingly natural and scientific solution to the fine-tuning problem. We no longer need coincidence or supernatural explanations. The quantum bounce, the holographic principle, the role switching of space and time, and cosmological natural selection. These mechanisms show that the universe inside a black hole model is not just a philosophical idea, but a physically consistent and powerful theoretical framework that can explain Webb's most surprising observations. But beyond all these theoretical structures, what is truly exciting is what this model tells us about our relationship with the universe. Because, if this is true, we are not just isolated beings lost in the middle. We are part of a cycle of creation, part of a universe preparing for the next stage. And this cycle connects our consciousness and our existence in ways we cannot even imagine. It's time to emerge from these theoretical depths and explore the most shocking and personal consequences of this connection. Because the greatest secret of the universe may not be hidden in telescopes, but within ourselves. And now, we reach the peak, and now we reach the peak. Because everything we have talked about so far was just the beginning of this moment. Put aside the technical details and theoretical frameworks. Now, we will witness those moments when the most powerful telescope in human history looks directly into the darkest secrets of the universe. These are not just numbers and graphs. These are the most shocking, most epic, most incredible stations of a journey into the heart of the cosmos. We are turning the tempo to the maximum. Because now we are coming to those moments where the limits of everything we know are pushed, paradigms collapse, and the doors to a new reality are opened. Get ready. Because the universe is now revealing its greatest secrets, and the first blow has landed, its name, dark energy itself. For decades, we knew the universe was expanding. But in the late 1990s, we discovered that this expansion was not slowing down, but was actually accelerating. This was a discovery crowned with a Nobel Prize. We named this mysterious acceleration dark energy, but we didn't know what it was. We only knew that it existed, and that it constituted about 68% of the total energy density of the universe. This was an incredible ratio. The vast majority of the universe was made of something we couldn't see, touch, or understand. But the black hole universe model offers a revolutionary explanation for this dark energy. According to this model, dark energy is a direct result of a process occurring outside our universe, in the parent universe. Think of it this way. Our universe is a massive black hole within the parent universe, and this black hole is not static. It is constantly swallowing matter and energy from the parent universe. This causes the event horizon of a black hole to grow. It is precisely this growth that is perceived as the expansion of our universe. So what about the acceleration? In this model, its acceleration is the increase in the growth rate of the event horizon. In other words, our black hole is getting more food from the parent universe. This demystifies dark energy. It is no longer a mysterious, just unknown force. It becomes a natural consequence of the dynamics of gravity and black holes. This is evidence of a physical interaction between two different universes. The expansion rate of our universe is determined by the dynamics of the parent universe. This is not just a theory. This is a claim that can be tested with observations. Because, if this is true, the expansion rate of the universe should not remain constant over time, but should change according to events in the parent universe. This created an earthquake in cosmology. Because, suddenly, the idea emerged that the fate of our universe depends not only on the matter within it, but also on an external reality that we can never directly see. This forced scientists to turn their telescopes not only outwards to understand dark energy, but also inwards to the physics of black holes. But the shocks didn't end there. Because the black hole model explained not only the expansion of the universe, but also why the universe appears so flat. This flatness problem is one of the biggest puzzles in cosmology. Our observations show that the geometry of the universe is incredibly close to the simplest imaginable geometry, Euclidean geometry, a flat surface. The critical density value of the universe omega is so close to 1 that it cannot be a coincidence. If the value of omega had deviated from 1 by just 10 to the power of -15, just 1 second after the Big Bang, the universe would have either already collapsed back on itself or expanded so quickly that galaxies could never have formed. This is a fine-tuning like trying to balance a pencil on its tip for billions of years. The Standard Model solves this problem with the theory of cosmic inflation. Because, according to this theory, the universe expanded at an incredible rate in its first moments, flattening out any initial curvature. This is like the surface of an inflated balloon appearing flat over a small area. But the black hole model, again, offers a simpler and more natural explanation. According to this model, our universe could be a brane on the event horizon of a 3-dimensional black hole within a 4-dimensional parent universe. The geometry of the event horizon of a 4-dimensional black hole is inherently 3-dimensional and flat. This is a result of complex mathematical calculations. Therefore, the flatness of our universe does not require any fine-tuning or an additional inflation period. It is simply a fundamental geometric property of the structure we were born into. We are living on the surface of a massive 4-dimensional sphere, and the surface of a sphere always appears flat locally. This idea created great excitement in the scientific community, because it offered the first concrete clues that our 3-dimensional universe might actually be part of a higher dimensional reality. This was no longer just a toy for theoretical physicists, but a hypothesis that could be verified by observations, and this showed that to understand the structure of the universe, we needed to look not only at astronomy, but also at more exotic fields like string theory. This was a paradigm shift. And now, the biggest blow, the most incredible discovery, quantum entanglement, a phenomenon that Albert Einstein called spooky action at a distance and refused to accept. But experiments that were awarded the Nobel Prize in Physics in 2022 proved that it is real, and its implications shook everything we thought we knew about the nature of reality. Here is the mechanism. Imagine 2 entangled particles created at the same time. Send them to opposite ends of the universe. When you measure the property of one, the property of the other is determined instantly, with no time delay, no matter the distance between them, even billions of light years. Does this mean that information travels faster than light? No, it means something deeper. It shows that these 2 particles are not actually separate things. They are, despite the distance, parts of a single unified system. Space does not separate them. This means the universe is not local. Everything is connected by an invisible web. Now let's apply this idea to the black hole universe model. If our entire universe came from a single point at the Big Bang, then every particle in the universe has been entangled with every other particle from the beginning. The atoms in your body could be entangled with the atoms of a star in the Andromeda Galaxy, with the atoms of a quasar at the farthest corner of the universe. This is not just a poetic idea. This is a necessary consequence of quantum mechanics. This means that the space between us is an illusion. We are inside a single, massive, indivisible quantum system. This aligns perfectly with the holographic principle. If our 3D reality is a projection of information on a 2D surface, then every point on that surface is instantly connected to every other point, just like a ripple on the surface of a lake affects the entire lake. This discovery fundamentally shook the scientific world, because it showed that we now have to think not just about matter and energy, but about the nature of information. The universe is not a collection of objects, but a network of relationships, and this network operates beyond space and time. This raised deep philosophical questions about consciousness, individuality, and the meaning of existence. And finally, the ultimate proof that brings all the pieces of this puzzle together: the cold spot in the cosmic microwave background, CMB radiation. The CMB is the radiation left over from the Big Bang that fills the entire universe, and it is incredibly homogeneous. Its temperature is almost exactly 2.725 Kelvin in every direction. But almost. Because precise measurements from the WMAP and Planck satellites revealed unexpected anomalies in the CMB map, small temperature fluctuations, and the most famous of these anomalies is the giant cold spot in the direction of the constellation Eridanus. This region is only 70 microkelvin colder than the surrounding sky. This may seem like a very small difference, but the size of this spot is enormous. It covers an area in the sky 20 times larger than the full moon, and according to the standard cosmology model, the probability of such a large and cold spot forming by chance is incredibly low, about 1 in 1,000. This is a riddle that has puzzled scientists for years. So what could this cold spot be? Many theories have been proposed. But one of the most provocative is the idea that this spot is the remnant of a collision between our universe and another bubble universe, a cosmic bruise. The black hole universe model provides a natural ground for this idea. If the parent universe is a foam constantly producing new baby universes, then it is inevitable that these bubbles will occasionally collide. Such a collision would leave an energy trace, a cold spot, on the boundaries of our universe, in the CMB, just like we observe. This is not a proven theory yet. But the cold spot is one of the strongest observational clues we have for the existence of a multiverse. Multiple universes. This is no longer just a theoretical possibility, but a measurable anomaly etched into the sky. And if this is true, it explains why all those impossible structures found by Webb exist. They are proof that our universe is not alone, that it is part of a much larger and more dynamic cosmic neighborhood. Dark energy, the flatness problem, quantum entanglement, and the cold spot. These 4 revolutionary discoveries all point in one direction. We're inside something much bigger. But what exactly does being inside mean? How does it affect our existence as individuals, our consciousness, and our destiny? Because half the deepest and most personal consequences of this discovery lie in a field we're just beginning to understand, the nature of consciousness. And for that reason, to grasp what being inside means, we must focus on one of the most fundamental experiences of human consciousness, the flow of time. Because this new model implies that not just space, but time itself may be an illusion. This is an idea that forces us to radically rethink our existence as individuals, our past, and our future. Now we will address the most personal and shocking consequences of these epic cosmological discoveries, how time, memory, and consciousness operate in this massive structure. Because the greatest secret of the universe may not be where we are, but when we are, and the answer is much stranger than we expected, and so the moment has come, the moment when time itself becomes an illusion. This may sound like a philosophical speculation, but the block universe model, born from Einstein's theory of relativity, shows that this is a physical possibility. Unbelievable, but true. According to this model, can past, present, and future are not separate things. They all exist simultaneously in a 4-dimensional space-time block. Just like every frame of a film strip exists at the same time, what we perceive as now is just a single frame illuminated as our consciousness moves through this block. The flow of time is an illusion, a trick of perspective. This means that every moment of your life, from your first breath to your last moment, exists forever in this massive cosmic structure. Nothing is lost, nothing truly passes. Does this mean a deterministic universe? Is our future already written? Not exactly. Because as quantum mechanics says that this block universe is not rigid and unchanging, but full of probabilities, the black hole universe model goes even further. If our universe is a holographic projection of a black hole's event horizon, then our 4-dimensional block universe is the result of the information on that 2-dimensional surface. And this surface is not static. It continuously receives new information from the parent universe. This means our block universe is also constantly being updated, rewritten. Even our past can change in light of new information. This created the effect of an atomic bomb in the scientific world, because it fundamentally questioned the principle of causality, the principle that the cause always comes before the effect. John Wheeler's delayed choice experiment showed that this is possible. An observation made in the present can determine the past of a photon billions of years ago. This means our consciousness is an active participant that creates not only the future, but also the past. This makes us no longer passive observers of the universe, but its co-authors. But if time is an illusion, what is memory? Aren't our memories real records of the past? This is where quantum information theory comes in, suggesting that memory is based on something much more fundamental than the neurons in our brain. Memory is the preservation of information. And in the universe, information is never lost. This is one of the most fundamental laws of physics. Even the information of a book falling into a black hole is encoded and preserved as quantum bits on the event horizon. Now let's apply this idea to our consciousness. Our brain is an incredibly complex quantum computer with about 86 billion neurons. Every thought, every emotion is the result of billions of quantum interactions between these neurons. Theories like ORC, orchestrated objective reduction, suggest that consciousness arises from quantum computations in protein structures called microtubules inside neurons. These microtubules may be directly connected to the fundamental space-time geometry of the universe. According to this model, what we call memory is not something stored locally in our brain. It is the entanglement of our quantum brain states with the larger holographic information field of the universe. When we remember something, our brain is actually tuning in to the information state of the universe at that moment and reaccessing that information. This means our brain works like a radio receiver. Memories are broadcasts, and when we tune to the right frequency, we can receive that broadcast. This could explain why some memories are so vivid and realistic, why traumatic events feel like they are being relived over and over. Because those moments are still there in the block universe, and our brain has remained in quantum entanglement with those moments. This idea built a revolutionary bridge between neuroscience and physics. Scientists began to study memory not just as a chemical process, but also as a fundamental physical phenomenon. This meant that human identity and personal history could be as permanent as the universe itself. And now, the most personal, the deepest question. If we are part of this massive, networked system, who am I? What is individual consciousness? This is a question that philosophy and religion have been asking for thousands of years. But now physics may offer a surprising answer. This answer lies in the concept of the hollow movement, developed by physicist David Bohm. This theory states that the fundamental nature of the universe is an undivided, flowing wholeness. Bohm divides reality into two levels, the implicate order and the explicate order. The explicate order is the three-dimensional world we perceive, made of separate objects and events. But this is just a surface. This explicate order unfolds, or is projected from a deeper, more fundamental reality, the implicate order. The implicate order is a realm of potentials where everything is intertwined. Just as every part of a hologram contains the information of the whole, every point in the implicate order contains the entire universe. According to this model, our individual consciousness is a vortex unfolding from the implicate order, just like a whirlpool in a river. The whirlpool appears to be a separate thing. It has its own shape, its own dynamics, but in reality, it is nothing other than the river itself. But beyond all this philosophical depth, perhaps one more question remains that is most important. Does this knowledge place a responsibility on us? If we are the mechanism through which the universe understands itself, how should we use this understanding? This takes us to a realm no longer just about what we are, but about what we should be. Because the next step of the universe may depend on the step we take, and therefore, this knowledge is not just an understanding, but also a deep responsibility. And so the moment has come, the moment when time itself becomes an illusion. This may sound like a philosophical speculation, but the block universe model, born from Einstein's theory of relativity, shows that this is a physical possibility, incredible, but true. According to this model, past, present, and future are not separate things. They all exist simultaneously in a four-dimensional space-time block, just like every frame of a film strip exists at the same time. What we perceive as now is just a single frame illuminated as our consciousness moves through this block. The flow of time is an illusion, a trick of perspective. This means that every moment of your life, from your first breath to your last moment, exists forever in this massive cosmic structure. Nothing is lost, nothing truly passes. Does this mean a deterministic universe? Is our future already written? Not exactly. Because the quantum mechanics says that this block universe is not rigid and unchanging, but rather full of probabilities. This meant that human identity and personal history could be as permanent as the universe itself, and now the most personal, the deepest question. If we are part of this massive, networked system, who am I? What is individual consciousness? This is a question that philosophy and religion have been asking for thousands of years. But now physics may offer a surprising answer. This answer lies in the concept of the hollow movement, developed by physicist David Bohm. This theory states that the fundamental nature of the universe is an undivided, flowing wholeness. Bohm divides reality into two levels, the implicate order and the explicate order. The explicate order is the three-dimensional world we perceive, made of separate objects and events. But this is just a surface. This explicate order unfolds, or is projected from a deeper, more fundamental reality, the implicate order. The implicate order is a realm of potentials where everything is intertwined. Just as every part of a hologram contains the information of the whole, every point in the implicate order contains the entire universe. According to this model, our individual consciousness is a vortex unfolding from the implicate order, just like a whirlpool in a river. The whirlpool appears to be a separate thing. It has its own shape, its own dynamics, but in reality, it is nothing other than the river itself. But beyond all this philosophical depth, perhaps one more question remains that is most important. Does this knowledge place a responsibility on us? If we are the mechanism through which the universe understands itself, how should we use this understanding? This takes us to a realm no longer just about what we are, but about what we should be. Because the next step of the universe may depend on the step we take, and therefore, this knowledge is not just an understanding, but also a deep responsibility. And so the moment has come, the moment when time itself becomes an illusion. This may sound like a philosophical speculation, but the block universe model, born from Einstein's theory of relativity, shows that this is a physical possibility, incredible, but true. According to this model, past, present, and future are not separate things. They all exist simultaneously in a four-dimensional space-time block, just like every frame of a film strip exists at the same time. What we perceive as now is just a single frame illuminated as our consciousness moves through this block. The flow of time is an illusion, a trick of perspective. This means that every moment of your life, from your first breath to your last moment, exists forever in this massive cosmic structure. Nothing is lost, nothing truly passes. Does this mean a deterministic universe? Is our future already written? Not exactly. Because the quantum mechanics says that this block universe is not rigid and unchanging, but rather full of probabilities, the black hole universe model goes even further. If our universe is a holographic projection of a black hole's event horizon, then our four-dimensional block universe is the result of the information on that two-dimensional surface. And this surface is not static. It continuously receives new information from the parent universe. This means our block universe is also constantly being updated, rewritten. Even our past can change in light of new information. This created the effect of an atomic bomb in the scientific world, because it fundamentally questioned the principle of causality, the principle that the cause always comes before the effect. John Wheeler's delayed choice experiment showed that this is possible. An observation made in the present can determine the past of a photon billions of years ago. This means our consciousness is an active participant that creates not only the future, but also the past. This makes us no longer passive observers of the universe, but its co-authors. But if time is an illusion, what is memory? Aren't our memories real records of the past? This is where quantum information theory comes in, and it suggests that memory is based on something much more fundamental than the neurons in our brain. Memory is the preservation of information, and in the universe, information never disappears. This is one of the most fundamental laws of physics. Even the information of a book falling into a black hole is encoded and preserved as quantum bits on the event horizon. Now let's apply this idea to our consciousness. Our brain is an incredibly complex quantum computer with about 86 billion neurons. Every thought, every emotion, is the result of billions of quantum interactions between these neurons. Theories like ORC-OR, orchestrated objective reduction, suggest that consciousness arises from quantum computations in protein structures called microtubules inside neurons. These microtubules may be directly connected to the fundamental space-time geometry of the universe. According to this model, what we call memory is not something stored locally in our brain. It is the entanglement of our quantum brain states with the larger holographic information field of the universe. When we remember something, our brain is actually tuning in to the information state of the universe at that moment and reaccessing that information. This means our brain works like a radio receiver. Memories are broadcasts, and when we tune to the right frequency, we can receive that broadcast. This could explain why some memories are so vivid and realistic, why traumatic events feel like they are being relived over and over. Because those moments are still there in the block universe, and our brain has remained in quantum entanglement with those moments. This idea built a revolutionary bridge between neuroscience and physics. Scientists began to study memory not just as a chemical process, but also as a fundamental physical phenomenon. This meant that human identity and personal history could be as permanent as the universe itself. And now the most personal fears the deepest question. If we are part of this massive network system, who am I? What is individual consciousness? This is a question that philosophy and religion have been asking for thousands of years. But now physics may offer a surprising answer. This answer lies in the concept of the hollow movement, developed by physicist David Bohm. This theory states that the fundamental nature of the universe is an undivided, flowing wholeness. Bohm divides reality into two levels, the implicate order and the explicate order. The explicate order is the three-dimensional world we perceive ancestors, made of separate objects and events. But this is just a surface. This explicate order unfolds or is projected from a deeper, more fundamental reality, the implicate order. The implicate order is a realm of potentials where everything is intertwined. Just as every part of a hologram contains the information of the whole, every point in the implicate order contains the entire universe. According to this model, our individual consciousness is a vortex unfolding from the implicate order, just like a whirlpool in a river. The whirlpool appears to be a separate thing. It has its own shape, its own dynamics, but in reality, it is nothing other than the river itself. It is just a momentary, local expression of the river. Therefore, your consciousness, my consciousness, we are all different expressions of that one, universal implicate order. We may look like separate waves, but we are all part of the same ocean. Does this mean that individuality is an illusion? No. It means that individuality is an expression of wholeness. You are a unique way for the universe to experience itself. You are a unique wave in that infinite ocean. And this once again removes consciousness from being just something in the brain. It places it in the very fundamental fabric of the universe. This means that consciousness is not just a tool for understanding the universe, but that we are conscious participants who create its meaning. But beyond all this philosophical depth, perhaps one more question remains that is most important. Does this knowledge place a responsibility on us? If we are the mechanism through which the universe understands itself, how should we use this understanding? This takes us to a realm no longer just about what we are, but about what we should be. Because the next step of the universe may depend on the step we take, and therefore, this knowledge is not just an understanding, but also a deep responsibility, and now it's time to explore what this responsibility means. If we are the mechanism through which the universe understands and experiences itself, how should we use this understanding? This question takes us to a deeper, more internal realm, no longer just about what we are, but about what we should be. Because this cosmic perspective changes the weight of our actions, our choices, and our values. This is a sacred space where science meets morality, where astronomy meets wisdom. Now we descend into the final philosophical layer of this journey, and in this layer, we will discover how the secrets of the universe are intertwined with the deeper secrets of our own humanity. Because, when we face this new knowledge, perhaps the most fundamental conflict is between free will and destiny. On one hand, there is the structure of the block universe and quantum entanglement, which suggests that everything is interconnected and potentially predetermined. If the past, present, and future exist simultaneously, and every particle is connected to every other by an invisible bond, do our individual choices really have any meaning? Or are we just actors in a cosmic script to assess and playing out our lines without knowing them? This idea that every action, every decision is part of a predetermined destiny can be an overwhelming burden for the human spirit. This is a tragic truth. Because, if a murderer's destiny is to be a murderer, and a hero's destiny is to be a hero, it could mean that praise and condemnation have no meaning. Where does responsibility begin and end? This creates a feeling of being deprived of our freedom, of being a puppet. This is one of the deepest fears of existence, the reality that we are not in control, the feeling of drifting like a leaf in the ocean, without the power to set our course. But here comes that beautiful but again. Yes, the structure of the universe may follow certain rules and connections. But John Wheeler's idea of a participatory universe reminds us that we are not passive actors in this script. On the contrary, we are the authors of this script. Quantum mechanics tells us that a system exists in a cloud of possibilities until it is observed. The act of observation collapses one of these possibilities into reality. Our consciousness is the mechanism that performs this observation. Therefore, yes, there may be a script, but what decides which scene is played, which line is spoken, is our observation, our consciousness, our choice. This gives us incredible power and responsibility. Destiny is not a pre-written book. It is a library filled with countless potential stories. And at every moment, we choose which book to read. Free will is not the absence of options, but the ability to choose among options. You two stand in the middle of this paradox. You two may have felt that events in your life are beyond your control, that you are a victim of fate. But at the same time, every day you make hundreds, thousands of small decisions. What to eat, what to say, who to be kind to. These decisions may seem insignificant, but they are actually the signatures you write on the fabric of the universe. Every choice you make creates a ripple in the ocean of quantum possibilities and pushes reality in a certain direction. Therefore, do not be crushed by the weight of destiny. Instead, realize the power of your choices. Because your free will is the most fundamental and most powerful tool through which the universe creates itself. But this process of creation leads us to another deep conflict, that delicate balance between pain and beauty. On one hand, there is the indifference and ruthlessness of the universe, natural disasters, diseases, losses, and death. These are an inevitable part of life. The universe does not seem to care about our happiness or our suffering. When a supernova explodes, it does not care about a nearby habitable planet. When an asteroid hits, it does not think about the destruction it creates. This is the harsh, cold, and sometimes meaningless seeming face of existence. This is a tragic truth. Because it means that no matter how good, how honest we are not exempt from pain and loss. This creates the feeling that life is unfair. Why do good people suffer? Why do the innocent die? There are no satisfactory answers to these questions. This is the silence of the universe. It means accepting that there is no cosmic voice to comfort us when we suffer. This is the darkest and most difficult aspect of existence. But here comes that but turn again. Yes, the universe may be full of pain, but it is also filled with unimaginable beauty. The colours of a sunset, the smile of a newborn baby, the harmony of a symphony, the sparkle in a loved one's eyes. These moments are as real as pain, perhaps more real. Because as pain often arises from the lack or absence of something, but beauty is born from the existence, harmony, and wholeness of something. Perhaps the universe gives us pain so that we can appreciate beauty more deeply, just as we would not know the value of light without darkness. Perhaps pain is like a hammer that breaks our heart, but but these cracks are the openings through which light can seep in. And the deepest compassion, the greatest wisdom, and the most unshakable love often arise from the greatest pain. This means that pain can serve a purpose. It can be a tool for transformation. You too experience this balance in your own life. You too have suffered, experienced losses, been disappointed, and in those moments, you thought life was meaningless and cruel. But you have also experienced moments of pure happiness, deep love, and breathtaking beauty. And perhaps you have noticed that what made you who you are, what made you stronger, wiser, and more compassionate, were often the difficult times. Pain can close you up, harden you, but it can also open you up, soften you, and make you more human. The choice is yours. Pain is inevitable, but how it shapes you is in your hands. You can see pain not as a force that destroys you, but as a teacher that leads you to a deeper understanding and a greater love. And this understanding leads us to one final philosophical layer, the simplest yet most powerful conflict that underlies everything: fear and love. And this understanding leads us to one final philosophical layer, the simplest yet most powerful conflict that underlies everything: fear and love. On one hand, there is a primal fear of the unknown, of loss of control, of loss, of death, and of meaninglessness. This fear is part of our survival instinct. It protects us from dangers. But it also limits us, diminishes us, and separates us. Fear builds walls. It causes us to see others as the other. It makes us selfish and defensive. The vastness and indifference of the universe can feed this fear. Fear of nothingness, fear of loneliness, fear of pain. This is the shadow side of existence. This is a tragic truth. Because a life ruled by fear is a life unlived. It means constantly expecting the worst, never fully realizing your potential, and never being able to form a real connection with others. Fear is the prison of the soul, and the walls of this prison are often built by our own thoughts. To see life as a series of threats means thinking that a danger is lurking around every corner. It means living in a constant state of anxiety and insecurity. But for one last time, here comes that wonderful but. Yes, fear is real, but there is a feeling that is more real, more fundamental, and more powerful than it. Love. Love is the desire to connect. It is the instinct to understand, to show compassion, and to unite. While fear builds walls, love builds bridges. While fear separates, love unites. While fear says I, love says we. And everything we have learned on this journey shows that the fundamental nature of the universe is not separation, but connection. Quantum entanglement, the holographic principle, the fact that everything comes from the same source. All these are physical clues that love is the fundamental law of the universe. Love is not just an emotional state. It is a reflection of that unified field that underlies the universe. When we feel love, we are actually resonating with the fundamental nature of the universe. You two are constantly making a choice between these two forces. Every day, every moment. Do you choose to be right in an argument, fear, or to understand, love? Do you choose to help a stranger, love, or to ignore them, fear? Do you choose to criticize yourself, fear, or to show yourself compassion, love? These choices determine your character and the direction of your life. And this new cosmic perspective can help us make this choice. If we're all parts of the same whole, to hurt each other is actually to hurt ourselves. If we're all connected, to help another is actually to help ourselves. To understand the universe is ultimately to learn to love better. Free will and destiny, pain and beauty, fear and love. These deep philosophical conflicts offer us a map of what it means to live inside a black hole. This is not just a scientific model, but also a philosophy of life. But to fully internalize this philosophy, we must take one more step. It is the transition from mental understanding to the wisdom of the heart. It is to discover how to weave all this knowledge into the fabric of our daily lives. Because the final destination of this journey is not outer space, but inner space, and in that inner space, the greatest secret of the universe is hidden, and therefore, the final destination of this journey is not outer space, but the inner one. This is the moment of transition from mental understanding to the deep wisdom of the heart and soul. Because the real art is to discover how to take all this scientific knowledge, these philosophical thoughts, and weave them into the fabric of our daily lives. It is the art of living in harmony with the rhythm of the universe. And now, in this last and deepest layer, we will examine the most personal, most transformative, and most hopeful consequences of our cosmic existence. Because the greatest secret the universe whispers to us is how to unleash the potential within ourselves. To understand this potential, we must perhaps confront the most fundamental conflict, the conflict between stillness and motion. On one hand, there is the infinite dynamic motion that underlies the universe, the tireless dance of electrons around atomic nuclei, the precise orbits of planets around stars, the majestic rotation of galaxies in space. The universe is in constant motion. It never stops. On the other hand, there is our desire for comfort, security, and stillness. We fear change. We cling to our habits. We want our lives to be predictable and controllable. This is like rowing against the current in a universe where motion and change are inevitable. This is a tragic truth. Because resisting change ultimately leads to pain and disappointment. Nothing stays the same. Relationships change. Our bodies age. The world revolves around us. Resisting this flow consumes our energy and hardens us. It is like trying to be a rock in the middle of a river. The river will eventually wear down the rock, shape it, and continue on its way. This resistance is a war against the natural flow of life, and it is a war that cannot be won. But here comes that beautiful but again. Yes, change is inevitable, but this does not mean we have to be tossed about like a leaf in the wind. It means we can learn to dance with the river, like a surfer riding a huge wave. We can use the energy of change to grow, to learn, and to transform. The motion of the universe is not a threat, but an opportunity. Every change holds the potential for a new beginning, a new possibility, a new adventure. Stagnation is death. Motion is life itself. This new cosmic perspective shows us that everything is interconnected and in a constant state of flux. Therefore, instead of seeing change as an enemy, we can see it as the universe's way of speaking to us. It is a guide that whispers to us where we need to be flexible, where to let go of the old, and where to move towards. You too experience this conflict in your life. You too sometimes resist change, taking refuge in the safe harbor of the familiar, but you also know that your greatest moments of growth, your most unforgettable experiences, were often the moments you left your comfort zone and stepped into the unknown. Therefore, when life sends you the next wave of change, do not retreat in fear. Instead, take a deep breath like a surfer, find your balance and get on top of that wave. Because when you trust the motion of the universe, you will discover that it will always bring you to where you need to be. But this motion leads us to another deep conflict, that eternal quest between meaninglessness and meaning. But this motion leads us to another deep conflict, that eternal quest between meaninglessness and meaning. On one hand, the universe itself seems to have no obvious purpose or goal. The laws of physics just work. They have no morals, no plan, no ultimate goal. The universe simply is. This gives rise to the idea that our own existence may be fundamentally meaningless. We might be small conscious gears in this massive indifferent machine, created by random chemical reactions. This is a tragic truth. Because living without a purpose can feel like a ship without a rudder. It creates an existential void, a sense of nothingness. If life has no ultimate meaning, why do we get out of bed in the morning? Why do we strive? Why do we dream? These questions echo in the deepest corners of the human soul, and when they remain unanswered, they can lead to despair. It is a cry for meaning that echoes unanswered in the great silence of the universe. But here comes that transformative but again. Yes, the universe may not give us a purpose spontaneously, but this does not mean we cannot create our own purpose. Perhaps the greatest gift the universe has given us is a blank canvas, and we have the freedom to paint this canvas with our own meanings, our own values, our own passions. Meaning is not something that is found. It is something that is created. And this act of creation is life itself. Our cosmic mission is to respond to the indifference of the universe with our own conscious meaning. This could be love, the pursuit of wisdom, creating art, helping others. The choice is ours. This gives us a divine power, the power to give meaning to a meaningless universe. You too are in the middle of this quest. You too want your life to have meaning, and sometimes, when you can't find that meaning, you may feel lost. But remember, meaning is not hidden in a great abstract idea or an ultimate goal. Meaning is hidden in the small moments, in daily actions, and in the relationships you build. In a child's smile, in a friend's support, in a job you do with passion, in a new skill you learn, meaning is how you live your life. Therefore, do not be crushed under the pressure of finding a great purpose. Instead, focus on creating a little bit of meaning every day. Say a kind word to someone, learn something you're curious about, appreciate the beauty of nature. Because when these small particles of meaning come together, they create a rich and satisfying picture, worthy of a whole lifetime, and your unique picture is the most beautiful and powerful answer to the meaninglessness of the universe. This answer brings us to the ultimate synthesis of this entire journey, that false dichotomy between science and spirituality. For centuries, these two have been seen as rivals. Science was considered the realm of reason, evidence, and the material world. Spirituality was the realm of faith, intuition, and the spiritual world. One seemed to exclude the other. This is a tragic truth. Because this separation has divided us from our wholeness. It has separated our minds from our hearts, our intellects from our souls. Science seemed cold and soulless. Because it could explain how the universe works, but it couldn't answer the why question. Spirituality seemed baseless and dogmatic. Because it lacked a verifiable foundation. This separation impoverished the richness of the human experience. It forced us to choose between either blind faith or a soulless rationality. But for one final and integrative but. As this journey has shown us, this separation is an illusion. When science delves into its deepest levels, it inevitably confronts spiritual questions. The origin of the universe, the nature of consciousness, the interconnectedness of everything. These are the questions that both physicists and mystics have been asking for thousands of years. And modern physics, especially quantum mechanics and cosmology, shows us that the universe may be a mysterious, web-connected, and conscious place, just as the ancient wisdom traditions have always intuited. Science can offer spirituality a new language, a new system of metaphors. Spirituality, in turn, can give science a purpose, a direction, and a moral compass. They are not rivals, but two different climbers ascending the same mountain. Both are trying to reach the summit, the desire to understand the mystery of existence. Science is the method of reading the poetry of the universe. Spirituality is the art of feeling and living that poetry. You too can realize this integration within yourself. You too can live with both your mind and your heart. You can turn to science to learn the wonders of the universe. But you can also embrace the awe, wonder, and sense of connection that this knowledge awakens in you. Knowing the chemical composition of a star does not diminish its beauty in the night sky. On the contrary, it deepens it. This means having both the curiosity of a scientist and the soul of a poet. It means being a whole human being. Stillness and motion, meaninglessness and meaning, science and spirituality. These final philosophical thoughts offer us a profound map of our place and potential in the universe. We now know that we are not just stardust. We are conscious beings through whom the universe knows itself, creates meaning, and unites in love. At the end of this long and deep journey, everything we have learned leads us to one final truth. The greatest secret of the universe lies not in the stars or equations outside, but within us, in that silent, wise, and loving center. And now, it is time to turn to that center and discover how to play our own unique note in this magnificent cosmic symphony. Because the journey actually begins now. On this long and deep journey, we have understood that we may be living in the protected womb of a giant black hole, and that everything is connected by invisible bonds. But what we have truly learned is that the fundamental note of this cosmic symphony is not fear, but love, not separation, but unity. You're a unique way for the universe to know and love itself. Because the greatest secret is not the vastness of the universe out there, but the silent depth of this universe within. And in that depth, silence is the most powerful answer. On this journey, we saw that the universe could be a giant black hole. But there's something I didn't tell you. What if this black hole, the universe itself, even you and I, are just a line of code? What if our entire reality is an incredibly advanced computer simulation? On our next journey, we will search for evidence of whether we are in the Matrix. Are you ready?